This is a very quick introduction to an important concept that we will develop throughout the course. It's called recursion. Recursion is where something is defined in terms of itself. Rather than get all mathematical, let's look at a simple example. You're at the end of the queue. You want to know how many people are in front of you. You can't just step out to count, as you'll lose your place. How can you find out how many people are in front of you if you can't see to the front? Here's a simple algorithm, a set of steps for solving the problem. You ask the person in front of you how long the queue is, then you add 1 to their answer. If they ask the person in front of them, then add 1 to that answer, you'll add 1 to them and you'll have your answer. Eventually, if your message makes it all the way to the front, the person at the very start will realise that the length of the queue in front of her is 0, so she'll turn back and say 1. The person after that says 2, the next 3, and so on until the person in front of you gives you a number, you add 1, and you know what your place number is. This is a recursive solution. Your position in the queue is equal to 1 plus the length of the queue in front of you. Position in the queue is defined in terms of the length of a smaller version of the queue. If there's a front to the queue, you'll eventually find it. Why does this work? It works because the queue is always getting smaller. We have a solid mechanism for making it smaller, and eventually we'll reach a point where there's only one person, and they can start the whole thing unraveling. We're going to use recursion for some of our data structure definitions, so now is a great time to do the optional Foundations Recursion Workshop code, which will help you to get practice at some skills that will come in handy. Don't worry if you don't have time now. We will be coming back to this later, and this section will always be here when you need it.